cases where the product turns out to be less than or equal to 4. Okay. All right. Let's look at part 6 now. Question number 6. It says, in a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y. Rajat, Sue, Tan, and 3 of these friends are 3 of these friends. Okay. Rajat, Sue, and Tan are 3 of these friends. The 8 friends will be divided into 2 groups of 4, 1 group for table X and 1 group for table Y. Find the number of ways in which this can be done if Rajat and Sue must sit at the same table as each other and Tan must sit at the other table. Okay, so they need to be divided into 2 groups. Okay, so we have 8 friends in total. Rajat and Sue must sit at the same table and Tan must sit at the other table. So we first have to handle these conditions that we're given. Rajat and Sue have to be placed on the same table. Now, what are the possibilities for that? You could place Rajat and Sue on either this table or on this table, right? It could be one of these 2 possibilities. Now, since the tables are labeled, so it does matter which table they sit on, okay? If they go to the first table, okay, but by the way, they are dividing them into 2 groups. They're not arranging them yet. Keep that in mind. There's no arrangement that's happening. They're just being divided into 2 groups. That means it's combination. It's not permutation, right? Because we're not doing any arrangement here. We're just splitting them into 2 tables like this. Now, in how many ways can we do this? One possibility is that Rajiv and Sue sit on this first table, and that person Tan sits on the other table. Now, how many options do we have for the rest of the people? How many people are we left with once we've placed Rajat and Sue here and Tan here? We have 5 people left. Those 5 people, we have to select 2 of them to place on table X. So we could say that's 5C2. Because Rajat and Sue are already placed there, the choice is only for the remaining people. Okay, how many people are we left with? 5 people. Out of those 5 people, we can say we have to place 2 more on table X. Or you could also think of it the other way around. You could say you have to place 3 more on table Y. So you could do either 5C3 or 5C2. Both of them are going to give you the same result. You could do any of them. So that's 5C2. Okay. However, it's also possible that Tan was on this table and Rajat and Sue were on this table. So they could switch tables. That's also possible. So for that reason, you multiply it by 2 because they could also switch tables, right? Tan could be on table X as well. So there are 2 possibilities for that. So 5C2 into 2, 5C2 is, I think, 10, 10 into 2, that's going to give you 20. So there are 20 ways of grouping these people like this. Does that make sense? Remember, we're not arranging them. So we're not arranging them in these seats yet. We're just splitting them in those 2 tables, dividing them into those 2 groups. Okay, let's move on. Question number 6 part B. Now it says, when the friends arrive at the restaurant, they now decide to sit at table X on the same side as each other. Okay, so now they have decided that they want to sit at table X. Okay. All right, so the question is, we are selecting 2 out of 5 people for table X. That's 5C2. Why are we not selecting the people for the Tan's table? Well, once you've selected 2 out of those 5 people, how many people are we left with? 3 people. all of those three people are just going to go to this table. There's nothing that you need to do for that. Even if you were to do write something for that, you would say that's 3C3. Select 3 out of 3 people. That's just 1. So it doesn't make any difference whether you write that there or not. Okay, you could write that 3C3. Choose 3 people out of 3. That's just 1. So it doesn't make any difference. Because once you have selected the people for table X, it's understood that the remaining people are going to go to table Y. So we don't really need to do anything for them specifically. Okay. All right. Now, when the friends arrive at the restaurant, Rajat and Sue now decide to sit at table X. So now we know that they are sitting at table X. So they have to be placed here. On the same side as each other. What does that mean? They could either be here or they could be here. There are 2 possibilities, right? They could either be on one side or the other side. Tan decides that he does not mind at which table he sits, so there's no condition for Tan now. Find the number of different seating arrangements for the 8 friends now. Now, what is the condition on? The condition is only on these 2 people, Rajit and Sue. In how many ways can we place these 2 people? We know they're going to be sitting at table X. First of all, they're either going to be sitting here or here. So there are 2 ways of assigning them the row in which they sit, right? There are 2 rows. Okay, let's do that. So we have 2 rows. There are 2 ways of placing them in one of those 2 rows. Let's say we have placed them in the first row now. Now they could either sit like this or they could switch places, right? So there are 2 ways in which they can switch places as well. So we multiply by 2 because of that as well. So 2 is for selecting which row they sit in. They either sit in this row or in this row. And then you multiply by 2 again to account for them switching places with each other, right? So that's Rajit and Sue handled. Okay. How many people are we left with? We're just left with how many people are we left with? We're left with 6 people. Now those 6 people have to be arranged in the remaining places. How many places are we left with? 1, 2, 3, 4, 5, 6. There's no other condition. Those remaining 6 people could be placed anywhere. We have 6 people left, 6 places for them. We could say that's just 6 factorial or 6p6. It's the same thing. And that should give you the result. 4 into 6 factorial. That's 2880. That's the result that we get here. Makes sense? So we only had to place Rajit and Sue there. Once they are placed, for the remaining people, there's no condition. So that's the 6 factorial. Because we have 6 places, 6 people, 6 factorial. All right. Okay, let's move on. Now it says, as they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of different arrangements of Rajit and Sue stand next to each other, but neither is at end of the line. Okay. Now, how do we think about this? There are 8 friends in total. They stand in a line. So we could represent them using these boxes if we want. Let's use the boxes representation. We have 8 friends in total. So we have 8 boxes for them. Okay, so we have these 8 boxes. Okay, Abubakar, let me get back to that in a moment. So we have these 8 boxes. These friends stand in the line. Now, Rajit and Sue, they stand next to each other. They have to be next to each other. So what do we do for that? We put them in a single box because we want them together, right? let's place them in a single box. Let's say we place them in a single box here, and that will have Rajid and Sue. And now we have to see in how many ways can we arrange these boxes. Now, if you think about it, this box cannot be on either side. It cannot be on this side. It cannot be on this side. So this box cannot be on the sides. Okay, so you have to keep that in mind. So how many options do we have for the boxes at the end? So for this box, for instance, how many options do we have for this box? For the first box, we have 8 friends in total. We have 6 options for this box, right? And then for the extreme right box, how many options do we have for that? If you have had 6 options here, apart from Rajid and Sue, we have 6 other people. So for this, for the person on the right side, for the place on the right side, we have 5 options left, right? So this is going to be 5. And now you've got these middle boxes left. Once we have filled out those boxes on the sides, in how many ways? 6 ways the first box, 5 ways the last box. Now we have these boxes left in the middle. How many boxes do we have here? We've got 5 boxes in the middle. Now they could switch places with each other, right? These 5 boxes. And how many ways can we do that? There are 5 boxes, so that's 5 factorial. So they could switch places with each other in 5 factorial ways. The boxes in the middle, that's what we're talking about. The boxes on the sides are fixed. We have placed one person here, and we have placed one person at the end. And now we're looking at the boxes in the middle, okay? So that's 5 factorial for these boxes. But then R and S, they could also switch places with each other. R could be on the left, S could be on the right. S could be on the left, R could be on the right. So we have 2 factorial for RS as well. Let's see what that gives us. 5 factorial into 2 into 30, and that's giving me 7200. That's 6 multiplied by 5 factorial into 2 factorial into 5, and that gives you 7200, and that gives you the result. That is one way of thinking about this. Okay, in permutation combinations, generally you have multiple ways of doing stuff. This is one relatively straightforward way of thinking about this. Since you do not want R and S on the sides, you have 6 other people left. So you say you have 6 options for the box on the left, you have 5 options for the box on the right, 6 and 5 for that. And then you have 6 people left, but R and S have to be together. So we have 5 boxes in the middle here, 5 factorial for those 5 boxes, and then R and S could switch places with each other as well, 2 factorial for that, just multiply everything, and that gives us the result. So, okay, Alman is saying, why do we write 6 on left and 5 on right? It doesn't matter. You can write 6 on right, 5 on left. So one of these boxes that you're filling first is going to have 6 options. And once you have placed one person in that box, the other box would have 5 options. So in one box, you would write 6 first, and the other you would write 5. You can start with any of them first. Okay. Is that okay? That's 7200, and that's our final result from the same session. Yes, Faizan, that's correct. That's correct. Okay. Find the number of different arrangements of the 9 letters in this word in which no consonant is next to another consonant. The letters D, M, N, and R consonants, and these are vowels. Okay, so the consonants do not have to be together. Let's highlight the consonants: N, D, R, M, D. Right? We have 5 consonants here, and 2 of them are repeated as well. They are 2 Ds. The consonants have to be separated. Now there are 5 of them. There are total 9 letters. So that means vowels and consonants, they are going to be occurring alternately, because we have 9 in total, 5 consonants and 4 vowels. If the consonants all have to be separated, we start by placing the vowels. We make 4 places for vowels: 1, 2, 3, 4. We could use that dashes and stars representation, remember? So the objects that you have to separate, you use stars for them, and the objects that you do not have to separate, you use dashes for them. So you start by representing the objects that you do not have to separate. Vowels are what you do not have to separate. You represent them here. So what are the 4 vowels that we've got? A, O, E, A. Okay, so the vowels are A, O, E, A. Now they could switch their positions with each other, and between them are going to be consonants. There are 5 places for consonants. There are 5 consonants. We have these places for them. Okay, and here we could have those 5 consonants. They are D, M, N. There are 2 Ds, and M, N, and R. This is where we could have those consonants. These are the positions where the consonants should be. Now, in how many ways can we arrange these? What are the possible arrangements for consonants? How many consonants do we have? 5, and there are 5 places for the consonants. And how many ways can we arrange them? 5 factorial, right? However, 2 of them are identical. They are 2 Ds. So because of that, we divide by 2 factorial. And what about the vowels? We have A, O, E, A. They can switch places with each other, right? Vowels can switch places with each other. How many vowels do we have in total? 4. So that's 4 factorial. However, 2 of them are identical. There are 2 A's. We divide by 2 factorial because of that. And that's going to give us the result. What do we get from this? 720. Okay, thank you. That's the result, 720. That was the first part. That's what you do here. Why can't we use total arrangements minus the arrangements of consonants together? Well, we can't do that because the question says no consonant is next to each other. If you do total minus together here, what that does is, out of the total arrangements, it just eliminates the case where all consonants are together. However, what about the case when 4 are together, C1, C2, C3, C4, and 1 is separated? If you do this case would also be counted, but we don't want to count that. We want each consonant separated. So there should be no 2 consonants together. So for this, you can't use that method where you subtract the arrangements where these are together from the total. This method is not going to work here because here you have to separate all consonants. No 2 consonants can be together. So that method does not work here. Okay. All right. So it says find the number of different arrangements of the 9 letters in the word, the same word, in which there is an A at each end and the D's are not together. Okay. Now, how do we think about this? There are 9 letters again. We can think of this box's representation. Let's represent those 9 boxes. We don't have to separate anything here. We just have to have, in fact, we do have to separate these. Let's think about how we could figure this out. There's an A at each end. That means the first letter on the left is going to be an A. The last letter on the right is going to be an A. These two are A's. Okay. How many places do we have in the middle now? We have 7 places left in the middle. We have these 7 places. Now A's are fixed. They are not going to move. So there's nothing that you have to do about A's. They are fixed there. And they're identical, so it doesn't matter if this A is there or this A is there. It doesn't matter. We are just fix those A's. So all we have to deal with is these 7 boxes in the middle. Okay. Now you could, here, since you don't only have 2 D's, you could use any of those 2 methods. You could do total minus together, or you could use the stars and dashes method. Both of them will work here. For 2 objects that need to be separated, both methods work. But for more than 2 objects, it depends which one of the 2 is going to work. Only one of those methods will work, depending on what the context is. If we want all of them separated, in that case, we have to use dashes and stars method. Otherwise, we can use total minus together. Now, in this case, since we only have 2 D's, we could use any of the 2 methods. What we can do now is we can say, of these 7 letters in the middle, what's the total number of arrangements? What are the letters that we have in the middle? We've got N, D, R, O, M, E, D. These are the letters in the middle. How many total arrangements do we have for them? 7 factorial, but then there are 2 D's. We divide by 2 factorial because of that. That's the total number of arrangements without any restrictions. Subtract from that the case when you have the 2 D's together. What happens when 2 D's are together? We can put them in one box like this. And then in the remaining boxes, we've got the rest of the letters, which are N, R, O, M, E. How many boxes do we have now? 6 boxes. All of them are different. No 2 boxes are identical now. So we just do 6 factorial for that. So this is total minus the case where the 2 D's are together. You subtract that case from the total, and that's going to give you the result. You can see what this turns out to be. What's this number? $1,800. Okay, thank you. That's the result that we get, 1,800. Part B. Now let's look at the next one. It says 4 letters are selected at random from the 9 letters in this word. Find the probability that this selection contains at least 1 D and exactly 1 A. Okay, now this is a very important question, and it's been coming repeatedly in the last few sessions. Okay, so try to ask questions quicker than that, so that they're answered before we move on to the next part. So there's another question. Let me just answer that quickly and then move on to the next one. So they're saying, why aren't we going to divide by 2 factorial? Divide 6 factorial by 2 factorial because we have 2 D's? Well, no, because we are only considering these 6 boxes. This is counted as a single box. Okay, this is counted as a single box. We are not treating the 2 D's separately at all. So we don't have to divide by 2 factorial as well. Okay. Here we were doing 7 factorial. We were dealing with the 2 D's separately. So that's why we had to divide by 2 factorial there. But here, this is one single box. All right, so we don't have to do anything for that. Okay, now this is very important. You will see this question very similar. So questions very similar to this in the last few sessions, and they've come repeatedly. It says find the probability that this selection contains at least 1 D and exactly 1 A. Now, the complete explanation of why we're going to do what we're going to do is going to take quite long. So I'm going to direct you to something that you can use to understand this. And And that is basically this particular video. I'll tell you the final result from this directly right now. Yeah. So look at that playlist that you have in the WhatsApp group. Look at that playlist and see this video. November. No, this is June. June 2021. Paper 5.2. Look at this video. Question number 6 in this. But I've explained why we are going to use the method that we're just going to use for questions like these. Okay? The whole reason for that. But for now, let me just tell you the result directly that you're going to remember. The logic of that you can find out in that video. But let me just tell you what you're actually going to do. Whenever you have probability, whenever you have to find probability, whenever you have to find probability of something, and you have combinations, but they're talking about selection, right? That means it's combination. And there is some repetition. You have repetitions in these letters. Some letters are repeated. When all of these things are there, what you're going to do is, to find probability, you're going to treat all letters as different. Treat all letters as different. As opposed to if you were not looking for probability. If you were, for example, looking for number of possible selections, if you were looking for number of possible selections that contain at least one D and exactly one A, if you were doing something like that, you would just list down the outcomes like this. At least one D out of 4. Since you want at least one D, that means one D is already selected. And you want exactly one A, that means one A is already selected as well. You have 2 options left out of how many? What are the remaining letters that we've got? You have A, N, D, R, O, M, D, A. These were the total letters. Now it says exactly one A. That means one A selected. So you can't use another A now. This is basically eliminated. One D is already selected as well. How many letters are we left with? We're left with N, R, O, M, E, D. All of these are different letters. If they had asked you for the number of possible selections, if they had asked you for number of possible selections that contain at least one D and exactly one A, you would do something like this. You would say, you want 4 letters. One of them has to be D at least. Exactly one has to be A. That means there has to be one D, there has to be one A. Now, what are the remaining letters that you can still choose from? Since there is exactly one A, you can't choose another A. So we eliminate the A's. You still can choose the second D. So we still have that here. How many letters do we have here? 6. Out of those 6 letters you want to, you would do 6C2 for that, and that will give you 15. Okay. If you were looking for number of selections, this is all that you would have to do. Sometimes you have to make some other cases for this as well. And that's what you would do. This method works for number of selections with combinations and repetitions. However, when they're asking for probabilities, you cannot do it like this. And the reason for that is each of the possible outcomes that you have, for example, one possible outcome is DA, one possible selection is DA, RO, for instance. Another possible selection is DARD. These selections do not have the same probabilities because there are 2 Ds and the remaining letters are only 1. So because of Ds being repeated, probability of each of these 15 outcomes that you have, they're going to be different. And since the probabilities are different, You can't use that formula, number of favorable outcomes divided by total number of outcomes, in this case, when you have to find probability. Okay, now you'll find a more detailed explanation of this. I've given you some hint of why this is not working. In that video, I'll actually remind me in the group. I'll share that particular video in the group today as well. What you need to do instead here is, for number of selections, you would do it like this. And I think most of you who would have tried this question, I think for finding probability, you would have done it. You would have, when you attempted, you probably did it the same way as well. However, when you're looking for probability, this method is not going to work. Why? Because the probability of each of those cases is different. Okay. Awesome. I'll share that video. In that case, I've spent like 20-25 minutes explaining this in detail, why we're doing this. But you just need to remember this eventually. And that is, you have probability, you have combinations and repetitions. When you have these three things together, when you're looking for a probability and you're using combinations and there's some repetition, you are going to treat all letters as different. That's what you need to understand. And you would treat it like this. You would say, okay, which letters do we have here? We've got A's. How many A's do we have? Make separate cases for A's. So you have 2 A's and you have D's. There are 2 D's. And the remaining letters are not repeated. So make separate cases for repeated letters. We have 2 A's, 1 and 2. We have 2 D's. What are the remaining letters? N, R, O, M, E. None of them is repeated. We could consider them all together. The letters that are not repeated, let's call them X. The remaining letters, how many of them are there? 5. What are the possible cases that you have here now that satisfy the condition? So you want at least 1 D and exactly 1 A. At least 1 D and exactly 1 A. Let's consider all the possible cases now. There has to be 1 A, so A has to be 1 in all of those cases. Okay, what are the possibilities for D? You could have 1 D and then 2 remaining letters. You could have 2 Ds and 1 remaining letter. In fact, there's no other possibility that you get here. These are the only 2 cases that you are kind of getting here. Is that okay? 1 A, 1 D, 2 other letters, 1 A, 2 Ds, and 1 remaining letter. There's no other case that you can think of. Now, in how many ways can you do this? For the first case, you are selecting 1 out of 2 A's, so that's 2C1. Remember, we are treating the letters as different. That's why we are saying 2C1. Otherwise, if the A's are identical, it does not matter which A we choose, right? We won't do 2C1 in general when we're looking for number of selections. But here, since we are treating all letters as different, we are saying one is A1 and the other is A2. We are selecting 1 out of those 2 A's. So it becomes 2C1. And then 1 out of the 2 D's, that's 2C1. And then 2 out of the remaining 5 letters, that's 5C2. And what about this now? 2C1 into 2C2 into 5C1. And that gives you the number of selections for each of these 2 cases that you have. What do you get from this? 2 into 2 into 10, 5C2 10. That's going to be 40. And the second case, 2 into 1 into 5, I think that's 10. And that's going to give you 50. These are the number of selections that satisfy the condition. And now, since you're looking for probability, what is probability going to be? Number of favorable outcomes divided by the total number of possible outcomes where you do not have any condition. What's the total number of possible outcomes without any condition? You have 9 letters. You have to select 4 out of them. That's 9C4. Again, we're treating all letters as different, so we can just do 9C4. Otherwise, if there's repetition, we can't use combination like that generally, right? But since we are treating all of them as different, the denominator is 9C4, and that's going to give you the result 50 over 9 C4, and that gives you 25/63. And that's the probability that you've got. Now, this is something that you need to remember now. Whenever you're looking for probability and you have combinations and there are repetitions, this is the method that you're going to use. For number of selections, you would use the other method. We will see when that comes in maybe another paper, and then we can compare these two as well. And I'll share that video with you where I've actually compared the two possibilities. What happens when you have number of selections? What happens when you have probability? That's a concept that you actually need to know about. So that's why I'm not going to spend too much time on that right now, but I'll basically refer you to that recording. It's like 25-30 minutes. I will look at that. You'll understand the logic of why we are doing this. Okay. What's the bar still here? Okay. Let's look at the last question now, and then we end. Okay. Now we have question number 6. Jay and his wife Kaz are having a party. Now he has invited 5 friends, and each friend will bring his wife. Okay. Now, at the beginning of the party, the 12 people will stand in a line for a photograph. How many different arrangements are there of the 12 people if he stands next to her wife and each friend stands next to his own wife? Okay, so the couples are standing together. Okay, so fine, let's do that at the end quickly. Okay, how many arrangements are there if 12 people, of the 12 people, if he stands next to his wife and each friend stands next to his own wife? So the couples have to be together. Okay, we have 12 people in total. What we can do is we can merge each pair of 2 boxes to get 6 boxes in total. So in each box, we would have a couple. Right? So we have 6 boxes in total. In each box, we have a couple. In how many ways can we arrange these 6 boxes? 6 factorial ways. In each box, there's a couple. For example, in the first one, you have J and his wife K. They can switch places with each other as well. And that's the same thing that happens with each of the other couples. They can switch their places. So we have to multiply it by 2 factorial because of that. And that's going to give us the result, 6 factorial into 2 factorial. That's 1440. Okay, that's the first part, quite straightforward. Okay, I'm sorry about that. I missed this. 2 factorial for 1. What about the others? We also have to do that. Into 2 factorial, into 2 factorial, into 2 factorial, into 2 factorial. How many couples do we have in total? What do we call them? Let's say C1, C2, or let's not call them anything. We have 2 factorial here, 2 factorial here, 2 factorial here, 2 factorial here. You have to do that for all of them, right? Because each of those couples can switch places. So that's 1, 2, 3, 4, 5, another 2 factorial. Or you could say 2 raised to power 6, right? And that will give you the result. Can somebody tell me what this number is? Six factorial into 2 raised to power 6. 2 raised to power 6 is 64. 64 into 6 factorial. That's 46080. That's the result that we get from this. 46080. That's the final answer. Okay, now it says how many different arrangements are there for the 12 people if J and Kaz occupy the 2 middle positions in the line with the 5 friends on one side and the wives of the friends on the other side. And we don't know which side the friends are going to be and which side their wives are going to be in. Okay, now let's think about this. So again, we have 12 places in total, right? And now what happens is this couple, the hosts, they occupy the places in the middle. So that means if we have these places in the middle, they occupy these two places. Let's actually put them in one single box here. And it's a fixed box, it's not moving. Okay, it's a fixed box. In this box, we have that host couple, J and K. Now, in how many ways can we arrange these two people? 2 factorial, right? They can just switch places with each other. Now, on one side, we are going to have the 5 friends. On the other side, we're going to have the 5 wives. Let's say we have the 5 friends on the left side. Let's suppose F1, F2, F3, F4, F5. In how many ways can we arrange these 5 people? In 5 factorial ways. Wives are on the other side. Let's say W1, W2, W3, W4, W5. In how many ways can we arrange those wives? 5 factorial ways. But then it's also possible that wives are on the left side and the friends are on the right side. So we consider that case as well. So there are 2 ways of basically moving around this outer box. It can go here or it can go here. So we multiply the whole thing by 2 factorial or just 2 because of that as well, because it's possible that friends are on the left side. The wives are on the left side and the friends are on the right side. The husbands are on the right side. That's also possible. So so what we get from this is 2 factorial into 5 factorial into 5 factorial for the friends and their wife. And then we have the middle 2 factorial for the host couple. And that's going to give you the result. 5 factorial is 120. 120 into 120 into 4. That's 57600. That's the result that we get from this. Okay. That was part 2. Let's look at the next one, part B. It says, for a competition during the party, the 12 people are divided at random. Now they're divided. They're not being arranged. They're divided. Divided means they are basically grouped. So this is going to be combination. Keep that in mind. They're divided at random into a group of 5. So group also gives you a hint that it's combination. The order does not matter. A group of 4 and a group of 3. Okay. Find the probability then that J and K are in the same group as each other. That's a 5-mark question. We need to find the probability that they are in the same group. Now, how many total possible groups are there, first of all, without any conditions? How many total possible groups are there if there were no conditions? Can we find that? The people are divided into a group of 5, 4, and 3. Total possible groups. One group has to be a group of 5, the other a group of 4, then a group of 3. You could choose a group of 5 first. So you would say 12C5. 5 people are put in one group. And then once they have been placed in a group, how many people are we left with? 7. So that's out of those 7 people. Now we have to choose a group of 4. That's 7C4. And once you have chosen these 2 groups, the third group is kind of already chosen now. The remaining 3 people, they're going to be in the third group. If you want, you can write it as 3C3. And that's going to give you the total number of possible combinations. Make sense? You could do it the other way around as well. You could say 12C4, as in you could choose a group of 3 first, and then a group of 5, and then a group of 4. Any order, it doesn't matter. It's going to give the same result either way. Okay, whichever group you choose first, it does not matter. What do we get from this? 12C5 into 7C4 into 3C3. What's this number? 27720. These are the total possible groups that we have. Now, what's the probability that J and Kaz are in the same group as each other? Now, we are not given which of the three groups they're going to be in, right? They could be in the group of 3, they could be in the group of 4, they could be in the group of 5. So we have to consider all of those different cases. So one possibility is that they are in the group of 5. If they're in the group of 5, think about it. So let me actually write it like this. This is a group of 5, then you have a group of 4, then you have a group of 3. You have 3 cases. One case that the couple is in this group. Second case, the couple is in this group. And third case, the couple is in this group. Right? These are the 3 cases that we've got. If the couple is in the group of 5, now they are already there, right? So there's nothing that we have to choose for that couple now. We have already placed them in the group of 5. That's what the first case is saying. What about the rest of the people now? We have 10 people left. Those 10 people left have to be placed in these 3 groups now. In the first group, we had 5 people in total. We needed 5 people in total. 2 of them are already selected. How many more people do we need for that? 3. So out of 10, we select 3 and put them in this first group. And then out of the remaining 7, we choose 4 and we put them in the second group. And then we have 3 people left. That's 3C3. Okay. Then you have the second case when that couple is in the group of 4. In how many ways can we select this now? Out of the remaining 10 people, we have to place 5 in this first group. And then out of the remaining 5 people after that, we need 2 more people for the second group. So that's 5C2. And then the remaining 3 people, they're going to be in the third group. And the last case, out of the remaining 10 people, we need 5 in this group. That's 10C5. And 4 in this group. Out of the remaining 5, that's 5C4. And then 1 person is left. That's going to go in the third group. 1C1, sorry. Calculate each of these cases and see what that gives you. What do we get from this? Each of these cases. Total for all is 80. And you're saying individually there are 4,200, 2520. Please do this calculation separately first. That will save you from careless errors. And then add them up together at the end. 7980. And now you can find the probability. These are the favorable outcomes. These are the total number of possible outcomes. What's the probability then? 7980 divided by 27720. And that should give you the correct result. Let's see what that turns out to be. 7980 divided by 27720. That's 19/66. That's what we're getting. That's our final answer. Is that okay? All right, good. Let's look at the next one now. So again, we've got a permutation question. Now it says find the number of different arrangements of the 8 letters in this word. Now, what's the how many letters are repeated? C, C. So we have 2 C's, and then we have O, O, O. We have 2 O's, and NED. All the other letters are different. We have 8 letters in total, so that's 8 factorial. Divide that by 2 factorial because of the 2 C's, and then 3 factorial because of the 2 O's, and that's going to give you the result. You can see what this is: 8 factorial divided by 2 into 6. And that's giving me 3360. That's the result that we get. Okay. Now it says find the number of different arrangements of the 8 letters in this word in which the first letter is O and the last letter is N. So now they have fixed two letters, one in the beginning and one at the end. So the first letter has to be O and the last letter has to be an N. Now, what are the remaining letters? We had 8 letters in total. We've got 6 letters left. In how many ways can we arrange these letters? Letters on the sides are fixed, right? So these are the remaining letters. How many letters do we have? We have C, O, C, O, E, D. These are the remaining letters. Okay, there are 6 of them. In how many ways can we arrange them? 6 factorial. But then how many of them are repeated? We've got 1, 2 C's. We divide by 2 factorial because of that. We have 2 O's. We divide by 2 factorial because of that as well. And that's going to give us the result. Let's figure this out. 6 factorial divided by 4, and that's 180. That's the second part of this. Okay, pretty straightforward again. Now it says find the probability that a randomly chosen arrangement of the 8 letters in this word has all 3 O's together. Now we're talking about arrangement. Arrangement means permutation, right? Find the probability that a randomly chosen arrangement of the 8 letters in this word has all 3 O's together, given that the 2 C's are next to each other. Okay. So the 2 C's, it's given that those 2 C's are next to each other. So when you find probability, remember in the denominator, you need to have the case that is given. This is what is given. The 2 C's are next to each other. Let's find this case first. When the 2 C's are next to each other, we have 8 letters in total. We have 8 letters in total. If the 2 C's are next to each other, we can combine them in a single box. So in one box, we have 2 C's like this. All right. Fardeen, let me go back to that in a moment. So given that the 2 C's are next to each other, so we have 2 C's together. This is what's given. In how many ways can we arrange this now? What are the remaining letters? The remaining letters are O, 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 N, E, D. In how many ways can we arrange these letters? All of these boxes, let's put them in boxes, in fact, because all of them have to be arranged. O, 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 N, E, D. Okay, so given that 2 C's are together in a single box, in how many possible arrangements are there? So this is the case where we have 2 C's together given. This is going to be the denominator in the probability formula. In how many ways can you do this? You've got 7 boxes in total. So you say 7 factorial. But then how many of these boxes are identical? You've got 3 O's in 3 different boxes. So we divide by 3 factorial because of that. And that is going to give you the total number of ways in which 2 C's are together. All right, let's see what this turns out to be. Remember, we're not dividing by 2 factorial for C's here because they're in a single box. We're not considering their arrangements with each other in the first place. So there's no point of dividing that by 2. Muazzam, that case will already be considered in that. The case that you're talking about, when you have 3 O's together, this also includes that case. When 2 C's are together, the 3 O's could be together or may the 3 O's may be together or may not be together. So that case is already incorporated in this. Okay, so the denominator includes all of those possibilities. Okay. All right, so this turns out to be 840. Okay, so this is 840. Okay. Now, out of these cases, why didn't we multiply by 2? For the C's, because they're identical. We don't have to consider their arrangements. If we had to consider them, we would say multiply by 2 factorial because there are two C's, but both of them are identical. Divide by 2 factorial as well. So it doesn't make any difference if we multiply that with that or not, because both of them are identical, right? Even if we do 2 factorial for the two C's, we have to divide by 2 factorial because both of them are identical. That's just one. So it doesn't matter if you consider that or not. Okay. All right. So these are the cases that we're going to have in the denominator. Now, out of them, in how many cases we've got the three? Yes.
Sir, the question said that the O's should be together. So why aren't we putting all the three O's in one box?
The question says find the probability that all three O's are together. Given that the two C's are together, so what's given is that two C's are together. For first of all, we are finding the total number of selections that are possible. So this is going to be the denominator in that probability formula. Now we consider that case where the three O's are together along with three C's being together. So that's the specific case that we have to find the probability for. So now consider that given two C's are together, in how many cases do we have the three O's together as well? Now we put the O's together in a single box as well. How many cases do we have for this? There are 5 boxes. That's just 5 factorial. All of those boxes are different. This is going to give us 120. This is the total number of possible outcomes that we will have in the denominator. And this is the number of favorable outcomes out of that total. So now that we have to find the probability, we say the probability in this case turns out to be 120 divided by 840. And that will give you something, 1/7, I think, right? 12/84, that should be 1/7. Does that make sense? So this was the case that was given. And this is the favorable outcomes that you have when you have both of those things together. When you have two C's together and three O's together. Here you've got both of these things true. This is the numerator. Like you do in the conditional probability formula, in the numerator, you have the case when both conditions are true. In the denominator, you have the case for what is given, right? So given was this. This is the intersection. We just do 120/840. You're actually finding these values from the table. That might be the 1 mark that you get, but you lose the first method mark and then the answer marks in the middle as well. Maybe 1, yeah, out of 4. All right, that was question number 6. Let's look at the last one now. It says, find the number of different arrangements of the 10 letters in this word in which the two C's are not together. So two C's should not be together. Now we're talking about two objects that we want to separate. For two objects, we can use both methods together, total minus together, that will also work. And we could also use the dashes and stars method, that will also work. So you can use any of those two methods, they will work. Okay. Total minus together and dashes stars method, both of them work. You can use any of them. So let's use the dashes and stars method. That will give us the answer directly. So we have two C's and 8 other letters. Let's represent the 8 letters with dashes that we do not have to separate. Yeah, that's 8. In how many ways can we arrange these 8 letters? 8 factorial ways. However, are there any repetitions amongst these 8 letters? Let me write them down on the side here. A, S, A, sorry, there's no C there. A, S, A, B, L, A, N, A. These are the remaining 8 letters that you do not have to separate. How many of them are repeated? A. Okay, you got 4 repeated. You divide 4 A's. You divide by 4 factorial because of that. and then the rest of them are all different. Okay, so 8 factorial over 4 factorial for the rest of the letters. And now what about the C's? C's could come in these gaps between them. 1, 2, 3, 4, 5, 6, 7, 8. There should be 9 gaps. Yeah, there are 9. In fact, 1, 2, 3, 4, there are 9 gaps. Okay. In these 9 gaps, you need to place the C's. You could do 9p2, but then both of them are identical. You would divide by 2 factorial because of that, because both C's are identical. Okay. Or you could also just do, in place of this, it's also okay to just do 9c2, because we could say we are choosing 2 places to place C's because their order does not matter. The C's are identical. It doesn't matter. In place of this, you could also just do 9c2. That will give you the same thing as well. Okay. So because of this, instead of this, you could also just do 9c2. And that should give you the result. You can see what that turns out to be. 8 factorial divided by, okay, so you're telling me 60480. That's what we get. Thank you. 60480. That's the final result. Okay. When can we use the dash and stars method, and when can we use the total minus together method? The dashes and stars method and the total minus together method, both of them work when we're talking about only 2 objects. With 2 objects, both methods work. Okay. With 2 objects, both methods work. But with more than 2 objects, it depends on which one of the 2 is going to work. So the distinction is, in one of them, you would be asked for none of. Let me show you an example of that. Okay. So one statement is going to look like this. Let's say you have some books and you have 4 physics books, and you want that not all physics books should be separated. If not all physics books should be together, if that's the question, not all physics books should be together, that means this case is not allowed, that all books cannot be together. However, 3 can be together and 2 can be together, that's okay. But all 4 cannot be together. In this case, you have to do total minus the case when 4 physics books are together. Okay. As opposed to when they say something like this, that with those 4 physics books, what you want is none of those 4 physics books should be together. That means even 2 cannot be together. So you don't want this case, you don't want this case, you don't want this case. None of these cases should be possible in the arrangement that you give. Okay. In such cases, when you have to separate all objects, no 2 can be together. In this case, you have to use dashes and stars method. In this case, total minus together would not work. You have to use this method. Okay. All right. Let's go back to this. This is 7 part A. Let's look at the next part. Now it says, find the number of different arrangements of the 10 letters in this word, which have an A at the beginning, an A at the end, and exactly 3 letters between the 2 C's. Okay, so how do we think about this now? We have an A in the beginning and A at the end. These 2 A's are fixed. They cannot move. They are fixed. Okay. In the middle now, how many remaining letters do we have? We've got 8 remaining letters. Let's represent them here. We've got 8 remaining letters in the middle. Now those 8 letters in the middle should be like this, that there should be exactly 3 letters between the two C's. Okay, there should be exactly 3 letters between the two C's. Now that means these 5 boxes have to look like this. C, and then C here. And then in the middle, you could have 3 other letters. That's 5, and then you have 3 other letters on the side as well. This is one possibility. This is one possibility, okay? Let's just consider this one possibility for now. How many arrangements would you have in this case? What are the remaining letters that you have not placed yet? The remaining letters are that you have to place in the rest of the boxes now. They are S, B, L, N, C, and 1 A is also left. Are there 2 A's left? There are 2 A's left. 1, 2, 3, 4, 5, 6, 7. How are they 7? There should not be a C there. Okay. These are the remaining letters. Amongst the remaining letters, we've got 6 letters. Out of them, 2 are identical. Now, in this possible arrangement, A's are fixed. We're not going to do anything with the A's. We're just talking about this part. If C's are in these 2 positions, in how many ways can we arrange the rest of the letters? We can arrange the rest of the letters in 6 factorial over 2 factorial ways. If the C's are in this position, the rest of the letters can be arranged in 6 factorial because there are 6 letters, divided by 2 because of these 2 repeated A's that we have in the middle. We've got 6 factorial over 2 factorial. This is one possible case. However, yes, we've got 3 letters between the 2 C's in this case, but what if the 2 C's move around a little? So what if we had something like this? That you had 1 other letter here, and then a C, and then 3 letters in between, and then another C here, and then 2 letters on the side. It could also be like this, right? Or you could have a C here and a C here with 2 letters on the left, and 1, 2, 3, 4 letters, 3 letters in the middle, and 1 letter on the right. That could be another possibility. You could also have something like this, that you have C here, and then 3 letters here, and then C here, and then 3 letters here. These are 3 other possible cases that you could have, right? Does everyone get that? These are the other 3 cases that are possible. Now, for each of them, we've got the same number of arrangements of these orange places, right? We've got 6 letters that we need to arrange in these places. In how many ways can we do that? Again, 6 factorial over 2 factorial, 6 factorial over 2 factorial, 6 factorial over 2 factorial. So we've got 4 cases like this. All of them are identical. We can just find one of them, multiply that by 4, or we can just add all of them up together like this. 6 factorial is going to give us 720. 720 over 2, that's 360. So 360 plus 360 plus 360 plus 360, or 360 into 4, that's going to give you 1440. That should be the number of arrangements that we get in this case. Is that okay? That's one way of looking at this. This is how you could do it. Make sense? Any problem with this? Can we do 4p1? 4p1, 4p1. What do you mean by that? For what? 4p1 for what? For p1 for what? After 6 factorial over 2 factorial? Are you saying multiply by 4p1? That will be 4, yes, but that does not make sense. Why 4p1? 4p1 means arrange 1 out of 4 objects. That's not what we're doing. You could multiply just by 4. That will make sense. But by 4p1. Permutation does not make sense there. Just multiply by 4. Just multiply one case by 4. And that will give you the result. Okay? Because all of them are going to have the same arrangements. All right, let's look at the last part now. Now it says 5 letters are selected from the letters in this word. In this word, find the number of different selections in which the 5 letters include at least 2 A's and at most 1 C. Remember that condition that we talked about in one of our earlier classes as well. Whenever these 3 cases are combined. Okay, no, in fact, we're not talking about probability. If we were talking about probability here, you would have to treat the letters as different as we did in one of our earlier classes. Did I share the video in which I explained the logic for that in the group yet? Or did I not do that? I think I told you that I'll be sharing the video in which I explained the complete logic of why we do that. Have I done that? Or not yet? I did, okay. All right. So if we were talking about probability along with combinations and there were repetitions, we would have to use that method. But here we're not talking about probability, we're just talking about number of selections. Okay. In this case, we just do it directly. So we need to select 5 letters. Okay. Select 5 letters, that means that's combinations out of 10 letters. We want the number of possible selections which include at least 2 A's. Okay, so there are 5 places, remember. You can choose 5 letters. Out of those 5 letters, we want at least 2 A's. That means at least 2 A's. 2 A's are already selected. 2 A's have to be there. No matter what you do, 2 A's have to be there. So what we can do is, from this word, we can just get rid of 2 A's. We can say 1 A is already selected and this A is already selected. Okay, so we don't have to worry about those 2 A's now because at least 2 A's have to be there. So 2 A's are already there. And at most 1 C, okay, so that's not something that we can say for sure, but 2 A's are already there. Now we just have to worry about the remaining 3 places. How many letters are we left with now? Let me write down the remaining letters here. That will make them simpler to understand. The remaining letters are C, S, B, L, A, N, C, A. These are the remaining letters. We've got 2 C's and 2 A's. In the remaining letters, we've got 2 C's and 2 A's. We are not thinking about those 2 A's. They are already selected. Forget about them. In all the cases that we consider, they're already selected. Okay. Just worry about the remaining 3 letters that we have to select. We've got 2 A's and 2 S. What we do is 2 A's and 2 C's. Whatever letter is repeated, we have to make cases for that. Okay. Whichever letter is repeated, we've got to make cases for that. C's and A's are repeated. In fact, for C as well, we might not need to make any case because we've got 2 C's. However, the condition states that we can have only at most 1 C. You can't have 2 C's anyway. So for C as well, you don't really need to make any cases as such. Just make cases for A to make it even more efficient. What are the possibilities for A? In the remaining 3 letters, one possibility is that you have no more A, so 0 A. Okay, if there's 0 A, let's forget about the C as well now, because let me repeat what I mean by that. It says there should be at most 1 C. That means out of these 2 C's that we've got, we can only have 1. So we can just get rid of one of these C's already as well. Sorry. We can get rid of one of these C's as well. And we can say we just have these 7 letters to choose from now. Right? Because it does not matter whether we have 2 C's or 1 C. At most, we can only have 1 C. These are the remaining letters. Now, if we have 0 A's, that means no A's amongst these 3 letters.
How many ways do we have to select these three letters? Which letters are we left with? C, S, B, L, N. Out of the remaining 5 letters, we have to select 3. That's going to be 5C3. Okay. And then the next possibility could be that amongst the from the remaining A's, we select one more A. If one A is selected, out of the remaining 5 letters, if this is also A, out of the remaining 5 letters, how many more do we have to select? 2. So that's 5C2. If we select 2 more A's, that means we have another A here and another A here as well. We've got only one place left. And how many letters do we have to choose from? 5. So that's 5C1. These are the 3 cases that we get. We can just add them up together. 5C3 is going to give us 10. 5C3, what's that? Yeah, both of them are 10. 5C3 is 10, 5C2 is 10, and then 5C1, that's 5. Add them up together, and that gives you 25. This is one way of doing this. Okay? This is probably the most efficient way in which you can't really, in which you have the least number of cases written like this. Okay? This is one possibility. However, if this looks confusing to you, an easier way to think about this could be that you just think of the repeated letters and make a number of cases for them, right? So what are the conditions? The conditions are you want at least 2 A's and at most 1 C. Let's make the cases for the repeated letters, all possible cases. Okay, which satisfy the condition, of course, at least 2 A's. So with A's, you could say you could have 2 A's and 0 C. You could have 2 A's and 1 C. And then with 3 A's, you could say you'd have 3 A's and 0 C and 3 A's and 1 C. Right? And then with 4 A's, you could have 0 C. And with 4 A's, you could have 1 C. These are all the cases that we get, right? Can you think of another case? At least 2 A's, that will be 2, 3, 4 A's. That's done. And then at most 1 C, that means it could be 0 C and 1 C with each of those cases, right? So we get 6 cases like this. Now, let's consider all of them separately. So now we have already made cases for A's and C. What are the remaining letters? S, B, L, and C, right? These are the remaining letters. S, B, L, N. In fact, no C as well. Yes, these are the remaining letters. And we had 5 places in total. Okay. Now, in the first case, we are saying we have 2 A's and 0 C's. So one A is already chosen, another is already chosen, and then we have A, C, A, A, C, A, and then A, C. These are already chosen. In those cases, these are already filled. Out of these remaining 4 letters, how many more do we have to choose? In the first case, 3 out of 4, that's 4C3, and then 4C2, 4C2, 4C1, 4C1, 4C0. Just add all of them up, and that's also going to give this up. 4C3 is 4, 4C2 is 6, 4C2 is again 6, 4C1 is 4, 4C1 is 4, 4C0 is 1. Add all of those cases, see what that gives you. 10, 10, 5, 25. This could be another way of thinking about this. Although we have to make more cases, but I think this is probably easier to figure out. All right. So basically what happens is whatever letter is repeating, you make cases for that.
All right. Now let's look at the next one. So the next question that you've asked about is question number 6, right? That's this one. Okay, let's have a look at this now. Question number 6 from this paper. It says a social club has 15 members, of whom 8 are men and 7 are women. The committee of the club consists of 5 of its members. Find the number of ways in which the committee can be formed from the 15 members if it must include more men than women. How many members do you need to select for that committee? 5 members. How many men do you have in total? You have 8 men. And how many women? You have 7 women. Now the number of men has to be more than women here. And the total has to be 5. What are the possibilities? One possibility is that you have 5 men and 0 women, right? Because 5 is also greater than 0. You also consider this case. There's no condition that says that it has to be at least 1 woman, I think. Let's say that here. Yeah. So this is also going to be one possibility, okay? 5, 0. Then you would have 4, 1. And 3, 2, and that's it. These are the 3 cases that you have, okay? Now in the first case, you say out of 8 men, select 5, and out of 7 women, select 0. In the second case, 8C4 into 7C1, and then 8C3 into 7C2. These are 3 cases that you have. You can just evaluate each one of these possibilities and then add them together. The first one is 8C5, that's 56. And then 8C4 multiplied by 7, that's 490. And the last one is 8C3 multiplied by 7C. And that's giving me 1176. And then you just add all of these numbers up and see what that gives you. That's 1722, right? 1722, that's the first part. Okay, that's all that you had to do here. Pretty standard combination question. There's no complication there as such. Now it says the 15 members are having their photograph taken. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. Okay, so we have 3 people and then 5 people and then 7 people. In how many different ways can the 15 members of the club be divided into a group of 3, a group of 5, and a group of 7? Okay, so out of 15 people, we need to make 3 groups, okay? One group has to have 3 people, so that's 15C3. And then from the remaining 12 people, you need to make a group of 5. That will give you 12C5. And then from the remaining 7 people, you need to have a group of 7, so that's 7C7. And that should give you the result. Now, you could do it in any order. You could also select this 7-member group first if you wanted. 15C7 into 8C5 into 3C3. You could also do it that way. Or any other order. It will give you the same result, whichever order you use. Okay? You can see what this turns out to be. 15C3 multiplied by 12C5 multiplied by 7C7, which is just 1. And that is giving me 360,360. That's the result that we get from this. Is that okay? That's the second part. Now it says in one photograph, these 7 people, let's call them A, B, C, D, E, F, G, are the 7 members in the back row. In how many different ways can these 7 members be arranged so that A and B are next to each other and F and G are not next to each other? Okay, so how do we think about this? A and B have to be next to each other. And these two people have to be separated, F and G. Now, since two people have to be separated, we could use any of those methods here. We could find the total number of arrangements and then subtract from that the cases where these two are together. Or we could use the dashes and stars method, keeping in mind that A and B have to be together. Okay, they have to be together. That means A and B have to be put in one box. Now, dashes and stars method is going to be easier here. Let's use that. We have 7 members in total. Out of them, we need to separate F and G. F and G need to be separated. Start from those people who do not have to be separated. That's A, B, C, D, E. How many places would we have for them? For people who we do not have to separate, we have 1, 2, 3, 4, 5 places for them. However, A and B have to be next to each other. So we put them in a single box or in a single dash. Let's put them in on one of these dashes, merge 2 dashes, and on that dash you have A and B placed. And then the remaining 3 dashes would have C, D, and E. Right? These are people who you do not have to separate. And then F and G have to be separated. We say they can come in these gaps now. 1, 2, 3, 4, 5. In how many ways can we arrange these people? In how many ways can we arrange these dashes? There are 4 dashes. We can say 4 factorial. And then A and B, they could also switch places with each other. We multiply this by 2 factorial because A and B can switch places. And then we think about these remaining 2 people. For those 2 remaining people, how many places do we have? 1, 2, 3, 4, 5. We have 5 places for those 2 remaining people. In how many ways can we arrange those two remaining people? We can say that's 5P2, right? Arrange those 2 people in these 5 places. That's 5P2, and that should give you the result. Okay? You can see what this turns out to be now. 960. Okay, so you're saying this turns out to be 960, and that is our final answer. That is what we were looking for. And that's it. Okay. Total minus together method in this case. Okay, let me also show that, how that would work. In this case, since you only have to separate 2 people, the other method would also work. If you had to separate more than 2, then that would not work. Okay, let's do the total minus together method. Total arrangements minus F and G together. Now, how do we think about this? In this total as well, keep in mind, A and B have to be next to each other, okay? Because we are using this method for this separation. In both of those cases, A and B still have to be together, right? So we find the total cases with A and B together, and we subtract from that the number of cases with A and B together, and also B and F, also F and G together. Let's find the total with A and B together, but for F and G, we say there's no condition in the first case. How would that look like? There are 7 people in total. We could use the boxes for this if we want. 7 people. We have 7 boxes for that. A and B, however, have to be together. So we merge 2 boxes and put A and B in that one box. On the remaining 5 people, we have no condition. So we say we have 6 factorial. for these boxes, and then 2 factorial for A and B switching places. Subtract from this the case when F and G are also together. So we've got the same boxes again. And now F and G are also together. So we also place F and G here, let's say, in a single box. How many total boxes do we have now? 5 boxes. So 5 factorial ways of arranging those 5 boxes. And then A and B could switch places in 2 factorial ways. F and G could switch places in 2 factorial ways. Find their difference, and that will give you the result. 6 factorial into 2 factorial minus 5 factorial into 2 factorial into 2 factorial. That also gives you 960. This could be another way of thinking about that. Okay, this is binomial distribution, right? This is normal now. And this is inverse normal. Because you have the probability given, you have to find the value of W. Okay, so you're saying that's doable. Let's do question number 6. That's the last question that we want to do today. It says, find the number of different arrangements of the 9 letters in the word activated. Okay, so there are 9 letters. That's 9 factorial. Let me see if there are any repetitions. A, there are 2 A's, so we divide by 2 factorial because of those 2 A's. There are 2 T's as well, 1 and 2. We divide by 2 factorial because of the 2 T's. And that's it. These are the repeated letters, and that should give you the result. 9 factorial over 2 factorial into 2 factorial. You can see what that is. 90720. Okay, that's the first part. Now it says, find the number of different arrangements of the 9 letters in the word activated in which there are at least 5 letters. Okay, at least 5 letters between the 2 A's. That means there could be more than 5 as well. So you have to consider that possibility that there are more than 5 letters between A's. But there have to be at least 5. Okay, now how do we think about this? There are 9 letters in total. Let's say we've got 9 boxes like this for those 9 letters. Okay, these are the 9 boxes that we've got. Now, A's should be placed such that there are at least 5 other letters between the 2 A's. Let's say there are 5 letters exactly between the 2 A's. How would it look like in that case? Let's say one A is here. 1, 2, 3, 4, 5. Another A is here. Let's say this is the case. With 5 letters in between, this is one possibility. Now, what about the arrangement of the remaining letters? What are the remaining letters? C, T, I, V, T, E, D. We still have 7 letters left, and out of those 7 letters, the 2 T's are repeated. In how many ways can we arrange those 7 letters in the 7 remaining places? We can arrange them in 7 factorial ways, 7 factorial divided by 2 factorial ways for this particular case. Okay. But then you could also have A here and A here, right? So this A, this whole thing, this whole set could also move between the 2 boxes, and it could also move on the right side. So there are 3 ways of basically placing this whole thing, right? In the current situation, both the boxes are on the right side. Both the remaining boxes are on the right side. In another possibility, one will be on the left and one will be on the right. And in another possible case, both of them will be on the right side. So there are three possible cases of placing the two A's such that there are exactly 5 letters between them. So for that, what we do is we multiply this by 3. Right? Because we would have 3 cases like this. Now that is what we get when you have exactly 5 letters. They want at least 5 letters. That means you can also have more than 5 letters. So what if you have 6 letters now? Let's think about that case. What if you have 6 letters? Let me just copy all of this. Now, what if you have 6 letters between the two A's? And then in the last case, we could say you have 7 letters between the two A's. Okay, so the second case is you have 6 letters. And then the last case would be you have 7 letters. Now, if you have 6 letters between them, again, you have 7 places and 7 letters left. 2 of them are repeated. 7 factorial over 2 factorial. And then this set of 8 letters, it's currently appearing here with the remaining box on the right side. It could also be that it appears on the right side and this box goes to the left. So there are 2 ways of having these 8 letters. In this way, the remaining box could come here on the right. It could also be on the left side. So for that, what we do is we multiply this by 2 because there are 2 ways of arranging this and this. Okay. And then the final case where you have 7 letters between the two A's. Now that's just 7 factorial over 2 factorial. There's no other way of placing the A's in this case, so it remains as it is. And now you just add all of these cases and you get the result. You can see what this turns out to be. So it's basically 7 factorial over 2 factorial multiplied by 6, and that should give you the result. Okay, 7 factorial divided by 2 factorial multiplied by 6, and that's given me 15120. This is what we get from this. Is that okay? No problems? Is it 12600? No, I'm getting this again, 15120. Yeah, it looks fine. Yeah. Okay. 5 letters are selected at random from the 9 letters in the word activated. Find the probability that the selection does not contain more T's than A's. Okay, so how do we think about this now? Remember what we discussed in our earlier sessions as well? Whenever we are talking about probability, this is probability. And we have combinations. We're talking about selection here. So this is combination. And there is repetition. There are some repeated letters. AA, TT. There is repetition as well. All of these things exist here. Whenever these 3 conditions are met, you treat the letters as different. Treat all letters as different. Okay, you would not consider the A's identical and the T's identical, because the problem with that is, we've talked about this in detail earlier, it basically skews the probabilities. The formula for probability where you do number of favorable outcomes. Divided by the total number of outcomes. That only works when each outcome has the same probability. The problem here is selecting an A has more probability than selecting a D, because there are two A's and there's only one D. So that is not going to work. If you find the number of favorable combinations, divide that by the total number of possible combinations, that formula is not going to work here. So the workaround for this that we use is we treat the letters as different. So we treat all letters as different. So A's, we would say this is A1 and this is A2. And we would say this is T1 and this is T2. All letters are treated as different. Okay, just keep that in mind, and then this becomes pretty straightforward. So we have some A's. How many A's do we have? We've got two A's. And then how many T's do we have? We've got two T's. And then the non-repeated letters, you can club them together. You can see how many remaining letters do we have. The remaining letters are 5 basically, right? Let's call them X, the remaining letters. Now the selection should not contain more T's than A's. What does that mean? What are the possibilities now? There have to be 5 letters, right? 5 letters need to be selected in total. And the T's should not be more than A's. Okay, so what are the possibilities? One possibility could be that you have no A and no T, and the remaining letters are all selected. That this is one possibility. Another possibility could be that you have, so with 0A, you can't have 1 or 2 T's because that will not satisfy the condition. Then T's should not be more. So 0, 0 is the only possibility. Then with 1A, you could have 0 T. That leaves us with 4 other letters. With 1A, you could also have 1 T. That leaves us with 3 other letters. With 2 A's, you could have 0 T's, 3 other letters. With 2 A's, you could have 1 T and 2 other letters. With 2 A's, you could have 2 T's and 1 other letter. These are the possible cases that you get. Now find the probability, find the combinations for each of these cases. What do you get? 2C0. So out of 2 A's, you want 0 in the first case. And out of 2 T's, you want 0 T's in the first case. And out of 5 X's, you want 5. Out of the 5 remaining letters, you want 5. That's the first case. Then the second case is 2C1 into 2C0 into 5C4. And then 2C1 into 2C1 into 5C3. 2C2 into 2C0 into 5C3. 2C2 into 2C1 into 5C2. And then finally 2C2 into 2C2 into 5C1. Evaluate each of these cases, add them up together and see what that gives you. Okay, the first one, 2C0 is 1, sorry, 1 into 1 into 1. This is going to be 1. Then you have 2 into 1 into 5, right? This is 10. Please confirm these calculations as well. 2 into 2 into 5, C3 is 10. That's 40. Then 1 into 1 into 5, C3, which is 10. 2C2 and 2C1, that's 2. 2 into 10, that will be 20. And then 1 into 1 into 5, that will be 5. What's the total that we get from this? Add them all together. 51 plus 10 plus 20 plus 5. That's giving me 86. What's the probability now? Probability would be 86 divided by the total number of possible combinations. You have 9 letters. Out of them, you have to select 5. In the denominator, you just have 9C5. Remember, we're treating all letters as different. So we can just use combination here like this directly, 9C5, and that should give you the result 86 over 9C5. That's given me 43 over 63. Okay, 43 over 63. That's the result that we get. Now we could write this in decimals as well if you wanted. That's 0.6825. That's 683. That's the probability that we get from this. Find the number of different arrangements of the 9 letters in the word alligator in which the 2 A's are together and the 2 L's are together. Okay, so when we want to keep some letters or some objects together, what do we do for that? We put them in a single box. So we can think of that box's representation. Make some boxes like this. How many letters do we have? We've got 9 letters. So we would have 9 boxes for them in total. So let's say we can place those letters in these 9 boxes. Now, what's the condition that we're given? The condition is that the 2 A's have to be together. If the 2 A's are together, we can merge 2 boxes to put 2 A's in that. The 2 L's are also together. We can merge 2 other boxes to put 2 L's in them. And now what are the remaining letters? The remaining letters are I, G, P, O, R. Okay. How many boxes do we have? In how many ways can we arrange those boxes? There are 7 boxes now. They can be arranged in 7 factorial ways. And there's no repetition. All the boxes are different, right? These 5 boxes are different. These 2 are also different. So we just say it's 7 factorial, and that should give you the result. If you want to think about arrangements of these letters as well, you can do that. It's not necessary because they're identical, but if you were to think about them, you would say number of ways of arranging A's is 2 factorial, but then both of them are identical. We divide by 2 factorial. And then similarly for L's, there are 2 letters, you say 2 factorial, but then both are identical. You divide by 2 factorial as well. You can do that if you want to, but it's not necessary because their arrangements are just going to be 1. There's only going to be 1 possible way to arrange the 2 A's and the 2 L's. So you can just ignore them as well because they're 1 in any case, and write down the answer directly. That we're saying is 5040. That's the first part. Make sense? 7 part A. Let's look at the next one now, part B. Now it says the 9 letters in the word alligator are arranged in a random order. Find the probability that the 2 L's are together and there are exactly 6 letters between the 2 A's. Okay, so how do we think about this now? Again, these 9 letters are arranged randomly. I'm going to make 9 boxes again. Just copy that. Okay, so let's say we got 9 boxes like before. We want to place those letters in these 9 boxes. What's the condition that we've got now? The 2 L's have to be together, and there are exactly 6 letters between the 2 A's. So wherever you place the 2 A's, there have to be exactly 6 letters between them, and the 2 L's have to be together. Now let's think of one possibility, right? Just to try to make sense of this. Let's say 1 A is here, let's suppose. Then there have to be 6 letters and then another A. So 1, 2, 3, 4, 5, 6, and then another A here. This is one possibility, right? There's only one other possibility, and that would be that you have 1 A on the right side and 1 A on the left side. 1 A on the extreme right, and then 1 A in the second box from left. Let me represent that here as well. The second possibility you could have. You have an A here and an A here. These are the only two cases that are possible. Okay, for the two A's. Now we have to think about the remaining letters. What are the remaining letters? L, L, I, G, A. Sorry, there's no A. G, T, O, R. These are the remaining letters. There are 7 remaining letters, and there are 7 remaining boxes. The two L's have to be together. What does that mean? Where can the two L's be? Can they be on the sides? They can't, because on this side, there can only be one L. So that means the two L's have to be in the middle somewhere between the two A's. Remember, these A's are fixed now. We cannot change A's. They are fixed. These positions cannot be changed now in both of these cases. It's either the first case or the second case. There's an or between them. It could be the first case or the second case. So we will find the number of cases from the first case, add to them the number of cases for the second case. Now the two L's are together. What we can do is, in the middle 6 boxes, we can merge 2 and place the two L's there. Merge any 2. Let's say we merge these 2. We place 2 L's here. Similarly, merge 2 boxes in the lower case as well. We've got 2 L's here. And then what about the remaining letters? They could come in any of these remaining places. Okay. Now, how can we arrange them? Now, we can't arrange all of them together now, because the problem is this box cannot go on the side. The bigger box, that cannot not go on the side. So we will have to arrange the middle boxes separately, and this will have to remain separate. But now the problem is, what are the remaining letters? The remaining letters are I, G, T, O, R. These are the remaining 5 letters. We also have this problem that which of those 5 letters are going to come here? There are 5 of them, right? So I, G, T, O, R. All of them cannot come in the middle because there are only 4 spaces left. One of them will have to go outside here. So we also need to consider how many possibilities do we have for the outer box, or how can we select the number of letters for these 4 boxes or the outer box. So you can do it either way. You can say, one way to think about this would be, out of these 5 letters, you have to put 1 letter in this place. In how many ways can you do that? You can do that in 5 ways. There are 5 different letters. You can say 5, or you can say 5C1, or you can say 5P1. All of them mean the same thing. There are 5 ways of putting a letter in this box at the end. All right. Once you have put 1 letter here, let's say that is O. It could be any of those 5. There are 5 options, right? What are the remaining letters now? If you place O, for instance, the remaining letters are I, G, T, and R. And they are going to be placed in these boxes, I, G, T, R. In how many ways can we do this arrangement now? For the middle boxes now, we could do 5 factorial, because there are 5 boxes, and we have to arrange those 5 boxes. None of them is repeated. So in how many ways can we do that? It's 5 factorial for the middle boxes. And then we say there were 5 cases on the side. We multiply these 2. What do we get? 5 factorial into 5. You can see what that turns out to be. This is 120 into 5, which will be 600, right? And then you do exactly the same thing for the other case. In the other case as well, you've got 5 options for this box on the side. So you can say you've got 5 options here. And then what about the boxes in the middle? Just like in the previous case, there are 5 boxes here. You can arrange them in 5 factorial ways. So for the second case as well, you've got 5 factorial into 5 ways. What do we get from that? 600. It's either the first case or the second case. Both of them have the same number of ways of arrangements. We can just add them up together, and that gives us 600 plus 600, which is 1200. There are 1200 ways of arranging them. You could also do it like this, that you could say there are two ways of placing the A's. So you could just find one. You could find arrangement for one possible case, that's 5 factorial into 5. And then since there are two ways of arranging or putting the two A's, you could say 2 into this, and that will also give you the same result. Of course, you could think of it either way. Now, let me know if there are any problems, any questions on this. And if you have another suggestion that you are not sure why it's not working, let me know. More easier way to do this question, since you have 6 letters between the two A's, handling this condition will be a bit complicated. One way to do this is also like this, that you, okay, this is another way to think about this. You could say, since we want 6 letters between the two A's, I'm not sure if it's going to be any easier. You have one big box, you've got one big box that has 8 letters. Okay, you've got one big box that has 8 letters. And then you have one box outside. That's the remaining letter. In how many ways can you arrange these outer boxes? 2 ways, so that's 2 factorial. But now the problem is, what do you do with this part in the middle? For that, you have to do the same thing again. You merge the two L's like this. And then in how many ways can you arrange these 5 boxes? In 5 factorial ways, and there are 5 options for the box outside, as in what you can fill that with. That's also 5. Eventually, it's almost the same thing. So yeah. All right. Yes, Fazan, that's correct. That's exactly what we're doing here as well. 5 factorial for the 5 places in the middle, and then yeah, it's the same thing. Exactly. That is going to be roughly the way that you think about this, right? So there's nothing that's much easier than this. No problems? Can we move on? In fact, we were looking for the probability. This is the number of arrangements for this, right? When the conditions are satisfied, we are actually looking for probability. What's the probability going to be? These are the number of favorable outcomes. What's the total number of outcomes? We will just divide it by that. Total number of possible outcomes without any conditions. There are 9 letters. So we say 9 factorial divided by the repeated letters. There are 2 L's and 2 A's. So we divide by 2 factorial and 2 factorial. And that will give you the probability. Okay, so in the denominator, we've got 9 factorial over 2 factorial and 2 factorial. And that should give you the result. Okay, what do we get? 9 factorial divided by 4, and then 1200 divided by that number. That's 5 over 378. This is what the probability turns out to be. In decimals, that is 0.0132. Make sense? Okay, let's look at the next part now. It says find the number of different selections of 5 letters from the 9 letters. Now we're talking about selection. Selection means combinations. We're not arranging them anymore. Which contain at least one A and at most one L. Okay, so how do you think about this? You can make cases for the repeated letters. Let's make cases for the repeated letters. Which are the repeated letters? You've got A's and L's that are repeated. So what possibilities could you have for the A's and the L's? Let's think about that. Could you have 0 A's and 0 L's? No, because there has to be at least 1 A, right? So one possibility is that you have 1 A and 0 L. With 1 A, another possibility could be that you have 1 L. Now the number of L's cannot be more than 1. So we just stop here for 1 A. Then another possibility could be that you have 2 A's. With 2 A's, you could have no L, or you could have 1 L. And that's it. These are all the cases that you've got. Now, since you want to select 5 letters, let's think about how these 5 places could be selected, how these 5 places could be filled. In the first case, A is already filled. In the second case, A and L are already selected. In the third case, 2 A's are already selected. And in the fourth case, 2 A's and 1 L is already selected. What are the remaining letters from which you have to do some selection now? I, G, P, O, R. How many of those letters how many are these letters? 5. Out of these 5 letters, in the first case, we have to choose 4. So that's 5C4. In the second case, out of those 5 letters, we got to choose 3. And then 5C3. And then finally, 5C2. You just add all of these cases up and you see what that turns out to be. 5C4 is 5, 5C3 is 10, 5C3 is 10, 5C2 is also 10. Add all of them up and that gives you 35. So there are 35 different possible selections out of these letters. Because now we have permutations and combinations. A group of 15 friends visit an adventure park. The group consists of 4 families. Mr. and Mrs. Kenny and their 4 children, Mr. and Mrs. Liza or Lisa, however you pronounce that, and their 3 children, and Mrs. Martin and her child, Mr. and Mrs. Nantis. Okay, so how many people do we have in total? We have 15 people in total. Okay, so these are 6. Then you have 5 here, 11, 2 here, and 2 here. Yeah, so that's total 15 people. The group traveled to the park in 3 cars. One containing 6 people, one containing 5 people, and one containing 4 people. The cars are driven by Mr. Liza, Mr. Martin, and Mr. Nantis, respectively. In how many different ways can the remaining 12 members of the group be divided between the 3 cars? Acha. Respectively means आपके पास अब first car में कितनी spaces बची? You have 5 spaces left in the first car. You have 4 spaces left in the second car, and you have 3 spaces left in the third car. Okay. अब बाकी 12 लोग रहेंगे आपके पास. अब क्या करेंगे? Remember, इसमें order matter नहीं करता as such, right? Because गाड़ी में बैठ के वो किस सीट पे कौन बैठ रहा है, that's irrelevant, right? तो बाकी 12 में से आपने क्या करना है? 5 लोगों को एक कार में प्लेस करना है. Let's do that. So you have 12. Out of those 12, you have to select 5 people for the first car. So that's 12C5. Now you've already selected 5 people. Okay? Out of those 12, जिनको आपने place कर दिया first car में, how many people are we left with? You're left with 7 people. Out of those 7 people, you have to place 4 in the next car. All right, so that's 7C4. Okay, and now how many people are we left with? 7 में से आपने 4 और place कर दिए. You have 3 left. उन तीनों को आपने यहाँ पे third में place कर देना है. That's just one way of doing this, right? बाकी तीनों उसमें चले जाएंगे. But if you want, you can write 3C3 there, and that should give you the result. Okay, let's evaluate this. 12C5 into 7C4 into 3C3, that's just 1, and that's giving me 27720. Okay, let's just write that here. इसमें आपने round off नहीं करना बिल्कुल, as it is लिखना है. Round off आप तब करते हैं जब आपके पास exact number नहीं आया होता. ठीक है? डेसिमल्स में कोई वैल्यू आ रही है उसको राउंड ऑफ कर लेते हैं. यू आर नॉट गोइंग टू राउंड दीज नंबर्स ऑफ. ठीक है, इसको पूरा लिखेंगे 27720. अच्छा. The group entered the park by walking through a gate one at a time. Okay, there are 15 people, right? Remember? Now, in how many different orders can the 15 friends go through the gate if Mr. 𝗨𝗨 goes first and each family stays together? Okay, so now this is permutation, right? We're talking about order. The order is important here. Let's say this is the gate. Is gate ke through na jana hai, right? And there are 15 of those people. Let's represent those people with boxes. Boxes representation यहाँ पे हम use कर लेते हैं. Okay, so there are 15 boxes in total initially. Okay, let me just draw those 15 boxes. We have one in the middle, and then we're going to have to divide the rest into 7 and 7s. We have, let's say, one here and one here. We have 1, 2, 1, 2, 1, 2, 1, 2. Okay, so these are 15 boxes in total, right? Which represent those 15 people. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so these are 15 boxes. ठीक है. अच्छा, अब इसमें conditions देखते हैं. Conditions क्या है? सबसे right side पे there has to be Mr. 𝗨𝗨. So we know in this box, सबसे right side पे, there's one person who has to be there, Mr. 𝗨𝗨. Okay. Let's represent him. यहाँ पे Mrs. 𝗨𝗨 भी है. Okay. तो हम ऐसा करते हैं. इसको हम चलें L से represent कर लेते हैं. This person is fixed. This person has to be there. Okay. इसको आप change नहीं कर सकते. He will be going first. Okay. Now each family has to stay together इनके बाद. Okay. अब अगर Mr. 𝗨𝗨 पहले जा रहे हैं, इनकी फैमिली तो इनके साथ ही होगी ना. वो तो पीछे नहीं जा सकती, तो उनकी तो अरेंजमेंट वो भी कहीं पे और नहीं जा सकते, तो ये एक तरह से फिक्स हो जाएंगे, राइट? मिस्टर 𝗨𝗨 के साथ इनके जो बाकी 3 लोग हैं, दे हैव टू बी देयर. ऑलराइट, आई होप दैट मेक्स सेंस. सो बाकी कितने लोग हैं इनके साथ? मिस्टर 𝗨𝗨 के साथ यू हैड 5 टोटल पीपल, द रिमेनिंग पीपल आर 4. तो आप क्या करेंगे? आपके पास एक बॉक्स होगा यहाँ पे, 4 बॉक्सेस को हम मर्ज कर देंगे, 2, 3, 4. ये 4 बॉक्सेस मर्ज करके हमने क्या किया? इसमें हमने बाकी लोग जो मिस्टर 𝗨𝗨 की फैमिली में है वो आ गए. सो मिसेस 𝗨𝗨 प्लस हर 3 चिल्ड्रन. सो देयर आर 4 पीपल इन दिस बॉक्स. ये यहीं पे रहेंगे. ठीक है, ये अब किसी और स्पेस में नहीं जा सकते. ठीक है, नाउ कीप दैट इन माइंड. अच्छा, अब बाकी फैमिलीज में भी इकट्ठे रहना है. वो कहाँ पर होंगी? देयर आर 3 अदर फैमिलीज. एक फैमिली में 6 लोग हैं. हम 6 बॉक्सेस और को मर्ज कर देते हैं. सो वी हैव 2, 3, 4, 5 and 6. Yeah, so we have 6 people here, Mrs. and Mr. and Mrs. K plus 4 children. So we have 2 here and plus 4 children. There are 6 people in total here. Yeah, 6 people from Mr. and Mrs. Kenny's family. 6 लोग यहाँ पर आ गए. And then the remaining 2 families have 2 people each. उनके लिए हमने यहाँ पे कर लिया. तो यहाँ पे हमारे पास 2 लोग आ रहे हैं M की फैमिली से, मिस्टर मिसेस मार्टिन की फैमिली से. We have Mr. and Mrs. Lantis. उनकी फैमिली से 2 लोग यहाँ पर आ रहे हैं. अच्छा, now we need to figure out इनकी arrangements कैसे करनी है. Mr. 𝗨𝗨 is fixed here. He is not going to move. Okay. अच्छा. His family is also here. His family also cannot move. Right? अब इनकी आपस में arrangements कितनी हो सकती हैं? इनकी आपस में arrangements कितनी हो सकती हैं? They can be arranged in 4 factorial ways. There are 4 people, right? इनकी अंदर बॉक्स के अंदर कितनी arrangements होंगी? 4 factorial. ठीक है. So this is handled now. Mr. and Mrs. 𝗨𝗨's family is handled now. ये साइड पर हैं, ये इनकी बाकी सबसे कोई ताल्लुक नहीं है. ठीक है, इनका और कहीं पे कंसिडर करने की जरूरत नहीं है. ये इनके 4 factorial ways होंगे अरेंजमेंट के, ये हमने यहाँ पे कर लिया. ठीक है. अच्छा, now we need to think about these remaining 3 boxes. ये आपस में भी अपनी पोजीशन चेंज कर सकते हैं, राइट? ये आपस में भी अपनी पोजीशन चेंज कर सकते हैं, इंटरचेंज कर सकते हैं. तो इसका क्या मतलब होगा? इन बॉक्सेस की कितनी अरेंजमेंट्स हो सकती हैं? फर्स्ट ऑफ ऑल, इन बॉक्सेस की आपस में कितनी अरेंजमेंट्स हो सकती हैं? देयर आर 3 बॉक्सेस इन टोटल. ये बॉक्सेस आपस में अरेंज कर सकते हैं 3 फैक्टोरियल वेज में. ओके, फैमिलीज आगे पीछे हो सकती हैं, पूरी की पूरी फैमिलीज, राइट? दैट्स 3 फैक्टोरियल वेज बिकॉज़ वी हैव 3 बॉक्सेस. अब इन बॉक्सेस के अंदर कितनी अरेंजमेंट्स हैं वो देखते हैं. We have Mr. and Mrs. Nantis family. In how many ways can they be arranged? 2 factorial. Then Mr. and Mrs. Martin's family, 2 factorial for that. Then Mr. and Mrs. Kenny's family, 6 factorial for that. So we have 2 factorial for this, and then 2 for this, and 6 for this. And 3 factorial for arranging these 3 boxes. ओके और फिर मिस्टर एंड मिसेस लेन, ये तो मिस्टर एंड मिसेस लाइजो, वो तो अपनी पोजीशंस, उनकी फैमिली जो है वो तो वहीं पे रहेगी, वो फिक्स्ड है. उनकी आपस में अरेंजमेंट कितनी हो सकती है? 4 factorial सिर्फ. You just multiply all of these numbers and that is going to give you the result. Okay, let's see what this turns out to be. 3 factorial into 2 factorial into 2 factorial into 6 factorial into 4 factorial, and that turns out to be 414720. That's your final answer. Okay, let's move on to part C now. It says in the part, the group enters a competition which requires a team of 4 adults and 3 children. In how many ways can the team be chosen from the group of 15 so that the 3 children are all from different families? Okay. ठीक है, adults पे कोई condition नहीं है. How many adults do we have? Let's count them. Mr. and Mrs. Kenny, that's 2. Mr. and Mrs. Liza, 2 more. Mrs. Martin, 1. And Mr. and Mrs. Landis. There are 7 adults in total, right? Or 8 children. So we have 8 adults in total. And, no, sorry, 7 adults. I counted 7. I wrote 8. 7 adults and 8 children. ये आपके पास total होगा, ठीक है? Now, out of 15, we have to choose this team. 7 adults में से कितने adults choose करने हैं? 4 adults. तो उनमें तो कोई condition नहीं है. That's just 7C4. Adults के लिए there is no condition, right? So adults can be chosen in 7C4 ways. That's straightforward. Okay. लेकिन जो children हैं, उनका क्या है? They have to be chosen all from different families. अब देखते हैं children कौन सी families में आ रहे हैं. Last family में children नहीं है. ओके, तो इसमें से तो कुछ नहीं यूज करना. बाकी तीनों फैमिलीज में से एक एक आपने चाइल्ड लेना है. तो फर्स्ट फैमिली से, मिस्टर मिसेस केनी की फैमिली से एक चाइल्ड लेना है. वो कितने वेज में हो सकता है? देयर आर 4 चिल्ड्रन. आउट ऑफ 4 यू हैव टू सेलेक्ट 1, सो दैट्स 4C1, राइट? सो आपके पास आ गया 4C1. यहाँ पे हम लिख लेते हैं, दिस इज फॉर एडल्ट्स, जस्ट टू मेक श्योर यू अंडरस्टैंड. ये हम ले रहे हैं मिस्टर मिसेस मार्टिन थे, केनी. मिस्टर मिसेस केनी की फैमिली से 4 में से हम 1 चूज कर रहे हैं, ठीक है? अच्छा, फिर हमें क्या करना है? मिस्टर मिसेस लाइजो के 3 चिल्ड्रन है, उनमें से एक चूज करना है. सो दैट्स 3C1. ओके, एंड देन मिस्टर एंड मिसेस मार्टिन हैव ओनली 1 चाइल्ड, तो वो तो 1 में से 1 चूज करना है. वो आप बेशक लिखें ना लिखें, एक ही बात है. एंड दैट्स गोना गिव यू द रिजल्ट. Okay, let's evaluate this and see what that turns out to be. 7C4 into 4C1 into 3C1 into 1C1. And that turns out to be 420. Okay, that's part C here. All right, let's move on to the next part. It says, in how many ways can the team be chosen so that at least one of Mr. Kenny and Mr. Lizo is included? At least one of them is included. Okay, अब देखें चिल्ड्रन पे तो कोई कंडीशन नहीं है ना? तो हम यहाँ पे लिख लेते हैं पहले. We have some adults and we have some children. अब देखें चिल्ड्रन पे कोई कंडीशन नहीं है. टोटल एडल्ट्स कितने थे? 7. Children were 8. And how many do we have to choose? 4 adults and 3 children. Children के लिए तो you just have to do 8C3. 8 children may say you have to choose 3 randomly. There's no restriction on that. Okay. Adults pay, there's a condition, and that is that at least one of Mr. Kenny and Mr. Lizo has to be included. या तो Mr. Kenny included होंगे या Mr. Lizo included होंगे या फिर दोनों included होंगे. ये नहीं हो सकता कि वो दोनों ही ना हो. अब इसमें 2 पॉसिबिलिटीज हो सकती हैं. या तो आप वो वाला केस निकालें जहां पे दोनों ही नहीं सेलेक्ट हुए और फिर टोटल नंबर ऑफ केसेस में से वाला केस माइनस कर दें. दैट्स वन पॉसिबिलिटी. या फिर आप इन सारे केसेस को अलग अलग कंसीडर कर लें. दैट्स आल्सो नॉट टू मेनी केसेस. आप डायरेक्टली कर लें. आप क्या कह सकते हैं? आप कह सकते हैं एक केस वो है मिस्टर केनी सेलेक्ट हो रहे हैं और मिस्टर लाइजो नहीं हो रहे. एक और केस हो सकता है मिस्टर केनी नहीं हो रहे और मिस्टर लाइजो हो रहे हैं. Right? And there's another possibility, Mr. Kenny select हो रहे हैं और Mr. Lizo भी select हो रहे हैं. These are the 3 cases that you have. Okay. Now, you have 7 adults in total. Out of them, you have to choose how many? You have to choose 4. 4 choose करने हैं total. अब इन 2 का तो आपने already decide कर लिया. First case, right? These are 3 different cases that you have. 1, 2, 3. फर्स्ट केस में आप कह रहे हो कि मिस्टर केनी को सिलेक्ट करना है और मिस्टर लाइजो को नहीं करना, तो बाकी कितने अडल्ट्स पे आपके पास चॉइस है? अब 7 में से 5 अडल्ट्स रह गए. उन 5 में से अब आपको क्या करना है? कितने और चूज करने हैं? मिस्टर केनी इज ऑलरेडी सिलेक्टेड. 4 टोटल करने थे, 3 और चूज करने हैं आपको. सो दैट्स 5C3. ओके. एंड एग्जैक्टली द सेम लॉजिक विल अप्लाई फॉर द नेक्स्ट केस एज वेल, बिकॉज 7 में से आपके पास चॉइस किन पर रह गई है? बाकी 5 के ऊपर. मिस्टर केनी और मिस्टर लाइजो को तो डिसाइड कर लिया ऑलरेडी कि मिस्टर केनी को नहीं रखना, मिस्टर लाइजो को रखना है. बाकी कुछ 5 बचे. उन 5 में से कितने और सेलेक्ट करने हैं? मिस्टर लाइजो ऑलरेडी सेलेक्ट हो गए हैं, तो 3 और सेलेक्ट करने हैं. दैट्स 5C3. एंड देन इन द लास्ट केस यू आर सेइंग मिस्टर काइनो और मिस्टर लाइजो दोनों सेलेक्ट करने हैं. तो टोटल 7 थे. 7 में से कितने बाकी बचे आपके पास? जिन पे चॉइस है आपके पास 5. कितने में से सेलेक्ट करने हैं? 5 में से सेलेक्ट करने हैं. 5 में से कितने सेलेक्ट करने हैं? अब आपको 2 ऑलरेडी सेलेक्ट हो गए हैं, 4 करने थे. So that's just 5C2. चिल्ड्रन का तीनों के अंदर क्या होगा? 8C3, 8C3. This is what we get from this. ठीक है, ये आपके पास 3 केसेस बने. All you have to do is just multiply them because you're saying 5 में से ये 3 adults चूज करने हैं and 8 में से 3 children चूज करने हैं. ये evaluate कर लें. ये सेकंड केस आ गया, ये evaluate कर लें. ये थर्ड केस आ गया, ये evaluate कर लें. इन तीनों केसेस को हम ऐड कर लेंगे and that's going to give us our final result. Let's do this. 5C3 into 8C3 into so what does that give us? That gives us 560. Second भी वही है 560. And then the last one is 5C2 into 8C3 and that is 560 as well. तीनों 560 आ रहे हैं. इन तीनों को ऐड कर लें and see what that gives you. That is 1680 and that's your final answer.
Second part, I think this looks kind of tricky. Let's actually do this question as well from this. The first part is fairly straightforward. You have 8 letters in the word reserved. They are arranged in a random order. Okay, 8 letters in this word are arranged in a random order. Find the probability that the arrangement has V as the first letter. So V has to be the first letter, E has to be the last letter. We have 8 letters in total. How many letters are we left with in the middle? 6 letters are left in the middle, right? These are 6 letters in the middle. Let's make 6 boxes for them. What are those 6 remaining letters? R, S, E, R, E, D. One E is there, V is there. Yes, these are the remaining letters, right? Now, in how many ways can you arrange these letters? There are 6 letters, 6 factorial, and then 2 R's, that's 2 factorial, 2 E's, that's 2 factorial, and that should give you the result. 6 factorial over 2 factorial and 2 factorial. All right? No, it should be 14C6 there. That's 14 people in total. That's 14C6. Okay, so you can see what this turns out to be. 6 factorial divided by 4, and that's giving me 180. And that's the result that we get from this first part. Okay. Okay, sorry, we were looking for probability. Yeah, you're looking for probability, right? So this is when you have V as the first letter and E as the last letter. These are your favorable outcomes. Now find the total number of possible outcomes if there were no conditions. Total possible arrangements, what would they be? If you consider all letters, we have 8 letters in total. That's 8 factorial divided by 2 factorial because of the 2 R's, and then 3 factorial because of the 3 E's. You can see what this turns out to be as well. 8 factorial divided by 2 and 6. That's 3360. And that should give you the probability. Divide these two numbers and see what that is. 180 divided by 3360. That will be the probability. That's 3/56, and that's what we were looking for in the first part. Okay, pretty straightforward. Just make sure that you find probability and not just the number of possible arrangements. We have to find probability. We have to find probability here. Okay, that's the result that we get. Okay, now let's move on. Now it says find the probability that the arrangement has both R's together, given that all 3 E's are together. Now, this is conditional probability. What is given has to be the denominator. When you're finding probability, what's given has to be the denominator. Let's find this case first of all, where 3 E's are all together. How do you find this case? Let's make this box's representation where the 3 E's are all together. That's the first case that I'm finding. Three E's together, because that's the that's the case that is given. That has to be the denominator of the probability formula. Okay, 3 E's together. We have 8 letters in total, so we can say we have 8 boxes. Since we want the 3 E's together, we can merge 3 boxes, put the 3 E's inside that single box. What are the remaining letters? The word was reserved, so the remaining letters are R, S, R, V, D. These are the remaining letters. In how many ways can we arrange them? There are 6 boxes now, that's 6 factorial. But then you have 2 boxes that are identical, R and R. We have to divide by 2 factorial because of that, and that will give you the result for this. E's are all identical, so we don't have to arrange them. 6 factorial divided by 2 factorial, that's 360. These are the number of outcomes where the 3 E's are together. That is what is given. This will be the denominator in that probability. Okay, remember the formula? Probability of A given B, that is equal to probability of A intersection B. That means where both of those things are together, are true, divided by probability of B. We have found this for now. Probability of what is given. Now, what is the probability that we want to find out? Both R's are together. So now we want to find the probability of this intersection. That all E's are together and both R's are also together. The intersection where both those conditions are true. Let's find that out. 3 E's together. That is still going to be the case, right? We're looking for intersection. And 2 R's together, both R's together, basically. In how many ways can we arrange this now? Again, we could consider this box's representation. We could say We had 8 boxes initially. We merged 3 of them and put 2 E's in them. And then what we can also do is we can merge 2 other boxes to put the 2 R's in them. And then we have 3 boxes left outside. And they would have the letters S, V, and D. In how many ways can we arrange this now? There are 5 boxes. We can arrange them in 5 factorial ways. They're all different, and that's it. We don't have to arrange E's and R's because they're all identical. We don't have to consider their arrangements. This is just 5 factorial, and that is 120. What's the probability then? Probability of intersection, that is 120, divided by the probability of what is given. That's 360. Not the probability. In fact, in the numerator, we have the possible outcomes when both conditions are true. In the denominator, we have the outcomes where 3 E's are together, the case that was given. Okay, you can see what this is. 120 over 360, what does that give us? 1 over 3. That's going to be our final result. So the probability is 1 over 3.